Be here in this webinar, and my presentation today would be about the traffic management and influencing driving behavior. So I will talk about these two things, how they interact each other on the crash incident based on the safe system approach. And actually, this PowerPoint I prepared it for presenting to the practitioners, those who design the roads and operate the system. And also 2 months ago, I presented this to the traffic police as well, because the traffic police in Thailand manage the traffic signal at the junction, and they should know the problem, how if they manage not properly, it's leading to the unsafe driving behavior and cause some accident. And here I would like to show you this case study. For the Thai people may already seen this situation. I hope you see the video.
Yes, we can see, sir.
Okay. There's a green light in this direction. Yes, that's happened. And the motorcyclist died at the point, at the situation, and the taxi driver cannot stop and hit, and he died, the driver. So what is the cause of the incident in the video? Human, vehicles, or roads and environment, or all of the above? And another question is, if human is the cause of the incident, who is responsible for the fatalities? The motorcyclist, or vehicle manufacturer, road designer, or operator, or all of the above? I think you may have some answer in your mind, and I like to use this theory to explain what happened in this junction. This is the basic theory for the traffic engineering. It's relationship of speed and flow and density. When for the on the highway, you can see that at the level of service A, there are less vehicles, so the speed are very high because of their low density. But flow, number of car passing to the point is less, number of the flow is low flow. And when number of car increasing, flow past the point is increasing as well, but the speed is reducing until the maximum flow we can get at this point, and optimum speed. That is the one thing on the highway. But in this situation, I like to use this graph at the bottom of the graph. At the junction, every car stopped at the junction. And when they got green light, vehicle increasing speed, flow is increasing up to some certain point. Though this situation is a high density, and we can get a maximum flow, the number of vehicles passing through the junction maximum per minute or per hour, and with the optimum speed. If the green light still on and on, so the vehicle would be speed would be increased, but flow is decreasing because it's low density. When the vehicle running separate and low density, that means number of car passing at the point is less and less, and speed is increasing. That point is tend to be dangerous as well because of high speed and actually low efficiency for the junction traffic management as well. So when we look back to the video, you can, if you remember that you can see the green light and then not many car moving at that point, and suddenly the motorcyclist going out. It seemed that motorcyclists waiting for a long time, and it's still red light for motorcyclists at that direction. But the other direction got green, but no vehicle moving. So it influenced some people, some driver can obey the law by running off the red light. So that happened. That's what happened at this video. And in terms of traffic management, we need to get the optimum cycle length to get the lowest delay time for all other junction. There are three direction that got red and one direction got green only. If the green light is too long for this, for example, for this direction, the other direction would get a long queue and waiting time is very long delay time. So the traffic signal should be get the optimum cycle length, and if not inappropriate, it influence the risk driving behavior as well. So the factor affecting crashes, we know that most of the time is human factors involved that accident, and some part relate to road and environment, and some part is vehicle, and there's some interaction between human error and road and the environment, including the traffic control is a part of the road as well. And for the factor affecting death, road user make mistake or misjudgment leading to further crash forces related to road design and speed limit as well. So it's interactions among road user mistake or misjudgment and the design and speed limit. So but when this happen, it tend to be result is fatality. That's not good. So I'm going back to the basic again about transport system, and actually any system, including three main parts. One is the fixed facility, which is in this case is road, and flow entity, it's mean vehicle and people moving on the fixed facility. And we need to have the control system. For other transport system like railway system, we have railroad, we have stations, and we have people and railway moving on the rail track. And the system control is really good in the railway system. They have automatic train system control supervision and automatic train protection, things like that. So they all automatically, and they become the vision zero. Never very few people die in the railway system. But in the road system, we have roads and environment is very dangerous, and we have a lot of vehicles and many types of vehicle, a lot of drivers that not follow the control system. And the control system itself is also not good, and road and the environment also not safe. So road system is become unsafe system. But what I mean is we need to fix all of this. We cannot only blame on the people who moving on the fixed facility and control system. I mean, the road and the environment need to be right and need to be safe, and the control system need to be good to control the situation as well. If you look at this direction at the top pictures, this is the motorcyclist point of view from the video. You can see the environment around this junction. The motorcyclist stop here, somewhere around here, and he cannot see the taxi driver running very fast from this direction, because this is the police box by him, that so he cannot see it. And what he seen is he saw the few vehicle passing through in a few minutes gap between the vehicle passing through, and he got a long red light so that he go out and then hit by taxi. In the bottom pictures is the taxi driver point of view. He came on this lens. You can see how many lanes: 1, 2, 3, 4, 5, 6, 7. 7 lanes for one direction. That means 14 lanes for both directions. It's more than 50 meters. The motorcyclists have to pass this junction, and taxi driver pass going this direction really fast because of he got a green light, and he afraid that it will be turned red soon. So he speeding and hit the motorcyclist. So the environment is not clear for both directions. If you see this video, it from the other direction. I can try to open these motorcyclists. Not no car passing, no vehicle, and one and a gap. It's a big gap between the vehicle. And then taxi came. So in terms of we always ask about what cause of the incident, who or what should we blame on, and usually the practitioner or the designer or those who control the system just blame on the driver who not follow the rule. But in terms of the safe system approach, we need to think about other factors as well. If we only blame on a single cause, it may be limit us to think about how to prevent the situation not happen again, and we cannot see other solutions. If we only blame on the driver, the motorcyclist, the solution would be like enforcement or education. That's all. But actually, if we change the questions, what are causes of driver behavior? So in this case is traffic signal control is not appropriate. That cause of the driver influence the driver behavior. And what cause of the fatality? The cause of fatality is the speeding. Taxi driver, it put the speed too high. If the taxi driver came slower, reducing speed, if there is speed limit on that road, it it it's in the city, the speed should not be like that. So if speeding lower that, the motorcyclists may not die even they have a crash. And who can do what uh, to reduce the severity? So these kinds of questions can think about who can do and what technology or how can we change the system to prevent the next fatality to happen. If we only blame on the driver, we won't change the system. And if the traffic signal still like that, it's just waiting for some days and someone would do it again and die again later on. So we need to think about the system as a whole. So in terms of the safe system approach, they said that if the road user fail to follow rules and regulations, the responsibility for improving the safety fall back on the provider and of the system. So this is the provider responsibility in terms of responsibility to foresee adverse consequence. So if we decided and build the system, those who are responsible for the system need to foresee what the consequence of the effects of the what happened after that. And so the answer of my two questions earlier is all of the above. We need to consider the human error and vehicle if taxi driver slower, less low speed and the braking system bad good because the taxi may be old and the braking system may not good as well. And road and the environment should be improved, like the traffic signal control should be improved. And also, who should responsible for the fatality? Surely the motorcyclist responsible, full responsibility for that because he not obeyed the rule and the vehicle manufacturer may think about the braking system or how to save the life, and road designer and traffic control should be change the operation of the traffic signal. And this picture on the highway in Thailand, it may be uh, easier to understand the situation easier than the video I show you. These kinds of roads, there are a lot of them in Thailand. They have four lanes and vehicles speeding very fast, more than 100 kilometers per hour. But the Department of Highway used the painted medians and put a lot of electric pole on the side road. And if driver fall asleep, make a error or not intend to obey the rule, but they may fall asleep, but and they cross the line to the other direction, there would be a head-on incident, head-on crashes. So that means people would die. And actually, it's happened already last year on this road, and 5 people died on a head-on incident, head-on crashes. And if someone fall asleep and then go off on the sideway, would be die as well because of the electric pole. But if they build the road like this, they have the raised medians and the um, guardrail at the side. Because of a lot of electric pole, they have guardrail. So if something happen, driver make a mistake or failure to control the vehicle, they will not die. No, the situation would be like slightly injury or no serious injury and no fatality. So this is a safe system. But still, the highway, the practitioner in Thailand should be understand more about safe system approach. And so in my concluding remark is, if we have unsafe system, we would generate the unsafe driving behavior, and then both have interactions. So if we cannot expect or have the 100% of safe driving behavior, surely we must have safe system first, and then we can generate safe behavior as well. So that system provider and user, both of them should have a shared responsibility to achieve Vision Zero. Right. So I like to end my presentation today that transport provider and road users should have shared responsibility, with provider foresee and mitigating adverse consequence, while road user complying with the rule and regulations. Right. So that's all my presentation. Thank you very much for your attention.